All right, guys. So we're going to work on our perfect squares today. So this is going to be for our perfect squares worksheet on Friday. So this is for perfect square, or I should say not perfect square root sheet. This is for our roots worksheet. And this is for Friday, 8/20. So I give you guys these. These are our perfect squares, and we're going to utilize them. Not sure why it's put. These are not negatives. I don't know what's going on with the formatting, so don't write a negative there. Those are not supposed to be there. I'm having formatting issues, so we'll just kind of work with it. So those negatives are not supposed to be there. It's just the square root of 4 equals 2. So it really looks like this. Square root of 9 equals 3. There's no negative there. So we've got our perfect squares right here. So we're going to take something like the square root of 24 right here. And what I'm going to do is I'm going to do this. Since 24 needs to be simplified, I'm going to take 24 and I'm going to say, okay, my next available square root below 24 is 16. Does 16 divide into 24? No, it does not. Then I go to my next available perfect square. Go to my next available perfect square, which is 9. 24 divided by 9. That doesn't work for me. Okay? Then I go to my last one, which is the square root of 4. So does 24 get divided by 4 evenly? Yes, it does. It becomes 6. So that means 4 times 6 is equal to 24. So if we can look at it that way, that means the square root of 4 times 6 is the same as root 24. So I can break it up into two pieces. Square root of 4 times the square root of 6. Well, what is the square root of 4? Well, from our little chart up here, the square root of 4 is 2. So the square root of 4 becomes 2. And so my answer is 2. That little dot means times root 6. That's how you deal with simplifying perfect squares. Go to the perfect square that is just lower than what you're looking for and start dividing it into it. So let's try a couple more here. These are quick little notes to help you guys out. So here's the other main concept, like terms. So if we're looking at this, I have a root 2 and a negative 2 root 3 and a negative 5 root 2. Well, let's just look at it this way. What if I had 1x minus 2y minus 5x? Well, I would combine my like terms here, and I would say 1x minus 5x minus 2y, and then I would go 1 minus 5x minus 2y, and so then I'd get negative 4x minus 2y. So the way we solve this problem is the exact same way we're going to solve these problems. I'm going to group them not by like term, but I'm going to group them by roots. So if you look right here, I grouped it by roots. Root 2's are together, and root 3's are together. And then all I did from there is I took the numbers that are in front. Don't forget, I'll see if I can write it. I'm not sure why the formatting is weird, guys. There's a 1 in front of it. So that means that, oops. Uh-oh, it's doing that. Watch out, guys. It's going to get all crazy and flashy on us. 1 minus 5 is negative 4 over root 2, which is negative. And then this has no common factors. So sorry about the flashing, guys. It'll be done here in a second. So if we look at this the same way here, I'm just going to go to a pointer, guys, so it doesn't flash on us. Okay. Oh, nope, it's going to flash on us. I don't know where my pointer is. I think it's locking up on us. So let's get through this real quick. So if we look at here, I have to take the perfect squares that I got to use my perfect squares to break these up. Sorry, guys, this is getting crazy. Shoot. I want to get through this video for you guys. Let's see if it lets me. All right. It's not going to let me. All right, guys. We'll just make it through, like I said. So if I take 8, I'm going to divide 8 by 4. So I end up with root 4 times root 2 right here. And then if I take 12 and break it up, I get root 4 times root 3. And if I take 32 and break it up, I get root 16 times root 2. Remember, we're looking for the perfect square that divides into it like the first problem we did. I would write it off to the side, but it's going to make some crazy, funky, weird thing going on here, guys. Let's see if that helps. Does that help? Nope, it doesn't help. And so once I do that, I get root 2 here. Root 4 becomes 2. So negative 2 times 2 becomes my 4 down here. And if I work my way across, root 4 is root 2. Root 16 right here is root 4. And then I end up becoming negative 2 times 2 is my root 4. And then I combined it with the negative root 4 over 2 that's over here on the right. And so then we end up with, let me do this real quick, even though it's going to flash on us, guys. Sorry. We're going to do that. And I'm going to do one more here. And then I combined those two here. That's what ended up becoming here. So those are my blue ones. And the other ones are my purple ones right here. Combine those two, subtract the coefficients like we did in the previous problem up here. And that's kind of how you tackle simplification. Sorry I couldn't write here, guys, but that first part of technology, got to be lovely.